Hello and welcome back to this course on Docker containers. In this video, I will discuss some of the very advanced Linux concepts that many beginners in the IT industry and Windows-only users will find it very difficult to understand. So please skip this section on Docker container secrets if you are a beginner in the IT industry or a Windows-only user. This section is for those people who have some Linux working knowledge and wanted to get better understanding on what happens under the hood in a Docker container. Now, with this disclaimer, let's get started. In this video, I will discuss some of the little known secrets about Docker containers. Many think that Docker somehow magically creates containers so that applications could run in a virtual isolated environment of their own. But the truth is, Docker does no magic. It is the Linux kernel that does all the magic. Docker is just a wrapper written on top of these Linux kernel primitives. In this video and the following videos, I will show you what exactly happens under the hood in Docker containers. I will try to break down some of the myths that many have on the magical nature of Docker containers. So let's get started. We already saw that containers are nothing but a group of processes running in a virtual, isolated and sandboxed environment of their own. The virtual isolated environment has a file system of its own, process ID numbering scheme of its own, has network interfaces of its own, devices, CPU and memory of its own. In the picture on the right, we have two containers running on the host machine. Each container has a file system, process ID, network interfaces, and storage disk of its own in the virtual environment. The CPU, memory, network interface, and storage disk you see inside the containers are not real, but virtual CPU, virtual memory, virtual network interface, and virtual storage disk. That's why it's called a virtualized environment. Only the host machine has the real CPU, memory, network interface, and storage disk. The containers get access to the real instances through the virtualization drivers running in the host machine. How Linux OS creates these virtual environments? Linux OS has virtualization primitives such as namespace and cgroups in its kernel. Linux has many virtualization tools and drivers such as libcontainer and libvirt to access these Linux kernel virtualization primitives. Docker container is nothing but a wrapper written on top of these Linux tools and drivers. Docker does no magic. It is the Linux kernel that does all the magic behind the screen. What is a namespace? Let's take a Java program for example. The variables or members of a class are visible only within that class. It is not visible or accessible by anything outside the class. Only the member functions of a class can access the members of a class. This is what is called as the namespace in the programming language. Similarly, in the Linux, there are several namespaces: a file system namespace, process namespace, network namespace, and so on. In the picture on the right, we see that the two containers have separate file system namespace, process namespace, network namespace, and device namespace of their own. This is separate from the file system, process, network, and device namespace of the host machine. For example, processes running in one namespace are not visible to other processes running in other namespace. They cannot access or talk to each other directly. We will discuss each one of these namespaces in detail in the next few videos.